Hello students, once again I am here with new video. After doing preparation and properties of haloalkanes, now I am starting chemical properties of haloarenes. We have done preparation of haloarenes previously, students. Chemical properties are left of haloarenes, so that I am taking today. First of all, I am telling you that haloarenes are less reactive than haloalkanes. This is very important question, students. Every alternate year or every year, some question is asked over it, that why haloarenes are less reactive than haloalkanes. क्यों कम reactive होते हैं haloarenes? What is the reason behind it? There are many reasons, but the main reason is resonance effect. Resonance effect meaning, students, as you know, halogen is attached over this benzene ring. Halogen, whichever is there, is having lone pair of electron. 3 lone pair of electrons are there. So this lone pair of electron gets shifted here in between X and benzene. So develop what here? Partial double bond character. This bond is going out in this way, and if it is coming out, it is giving negative charge. This negative charge will come inside, this bond will come outside. In this way, resonance will take place here. And due to resonance, what is happening in between X and this benzene? What is coming? Partial double bond is developing, and thus this cleavage becomes difficult. For the reactivity of haloarenes, this cleavage is required. And if it is not getting cleaved, that means reactivity is less. So here the main reason, if this question comes, we have to write due to resonance, haloarenes are developing partial double bond character, and thus this C or benzene, in between benzene and X, the bond cleavage becomes difficult. That's why the reactivity of haloarenes is less in comparison to haloalkanes, because in haloalkanes no resonance is there, no partial double bond is there, only single bond is there, and that's why it easily can be broken. So haloalkanes are more reactive. This is the first reason. Second reason, as you know, every carbon in the benzene ring is showing sp2 hybridization. So sp2 hybridized carbon is the second reason. What is happening if carbon is showing sp2 hybridization? If sp2 hybridization is there, more is the S characteristics. While in case of haloalkanes, sp3 hybridization is there. sp3 meaning S character is only 25% and 75% P character is there. But in case of sp2, here we can say S character is 33% and P character is 66%. 2 hai P or S1 hai. So here more S character is there in comparison to this haloalkanes. वहाँ 25% था S character, यहाँ 33% हो गया. More S character, so more will be the electronegativity. If more electronegativity, more will be the force of attraction between C and X, that is carbon of benzene. And bond length, this bond length decreases. More is the force of attraction between these two. Less is the bond length. अगर bond length कम हो गई है, तो more amount of energy will be required to break this bond. So again we will say that reactivity is less. Here I have written bond length will be less and more amount of energy will be required to break this CX bond in haloarenes. Okay, students. So this is one more reason why haloarenes are less reactive. Third reason is also there, students, but I am suggesting you that whenever this question is asked, you have to write partial double bond character is the main reason. Here I am telling you that third reason also, instability of phenyl cation. What is this phenyl cation? As you know, benzene ring with one X over it. If cleavage is taking place, heterolytic cleavage will take place, this shared pair of electron will move with X, and this type of cleavage will take place which develops positive charge on benzene ring. So this is called phenyl cation. It is not formed, बनता ही नहीं है. So again we can say that because of instability of phenyl cation, reactivity of haloarenes is less. So we have done that haloarenes are less reactive than haloalkanes. Okay, students? But under drastic condition, as we do in chemistry, students, that usually that is not reacting, but under drastic conditions like temperature and pressure, if increased, that particular substance can react. So under drastic conditions, they can show nucleophilic substitution reactions. ये भी दे सकते हैं nucleophilic substitution, but drastic conditions चाहिए. Like if I am taking chlorobenzene here, reacting with NaOH or KOH, like we did in case of haloalkanes also. Aqueous KOH, if we take in haloalkane, that gives alcohol. Here also I have taken this NaOH. If I will not mention these conditions, students, remember that 623 Kelvin and 300 atmospheric pressure, no reaction will take place. अगर ये conditions नहीं होंगी तो reaction हो ही नहीं सकता. If you write down in the exam without these conditions and you are preparing the products, that will be absolutely wrong. Because of less reactivity of this chlorobenzene, these conditions are required. And when these conditions are taken, intermediate substances obtained. Sodium phenoxide. Here, this HCl is eliminating out, ONa is getting attached over this benzene. Now, that intermediate get converted into final product, like in presence of dilute HCl or in H plus medium, what we will get? Phenol we will get. So in case of reaction of chlorobenzene with NaOH or KH under this condition, we are getting what? Phenol. Remember, friends, this is the manufacture method of phenol and it is called Dow's method. Name reaction, important reaction. So this is one of the nucleophilic substitution reaction in haloarenes. Next substitution we are taking is by amino group. These all we did in case of haloalkanes also, students. Alkyl halides में भी हमने किया था, but no drastic conditions were required there. No special conditions were required. But here, if suppose we are performing substitution by amino group, reaction with ammonia will take place. Here the presence of catalyst cuprous oxide is required along with the conditions 475 Kelvin and 60 atmospheric pressure. In this case, what we are getting? Aniline, C6H5NH2. You have to remember this product only mainly, students. Here Cu2, Cl2 and water are the byproducts, but I am asking you to remember the products actually, because these all chemical properties will be required in case of conversions. After completing this chapter, I will give you many conversion students and you go through that all from your sincere efforts. You can able to do chemistry nicely, students. From your sincere efforts, I am repeating it. Okay, students. Now the next is reaction with metals. This also we did in case of alkyl halides. Here, if this bromobenzene I am taking and reacting with magnesium, direct combination is taking place, students. C6H5MgBr. Okay, students, like in case of alkyl halides Grignard reagent, here also we are getting aromatic Grignard reagent C6H5MgBr. There RMgX we were getting. Here R was the alkyl group, here R is the aryl group, C6H5MgBr. So this is reaction with metals. Woods reaction also we did in alkyl halides. So here also we are taking that. Like both of the compounds are of bromobenzene, here I am taking. With sodium, if it is reacting in presence of dry ether, NaBr is eliminating out. NaBr, 2 molecules. And both of the benzene rings are getting connected with each other. That is called biphenyl. क्या बोलते हैं इसको हम? Biphenyl. दो फिनाइल ग्रुप्स आपस में जुड़ गए हैं. Okay, students, and suppose if I am taking one is the aryl halide and other is the alkyl halide. In presence of sodium, again I am taking in presence of dry ether. In this case also this NaCl is eliminating out, but the product which we are getting is one is the benzene ring here and other is the alkyl group. So our aryl alkyl group both are present here. This is called toluene, students. On benzene ring, when CS3 is there, toluene we are getting. So remember one thing here, students. If both of the alkyl groups are reacting, Rx plus Na plus Rx giving Rr, that we did in case of alkyl halides, that is called Wood's reaction. But if both are the aryl halides, in that case it is called Fittig reaction. Fittig बुलाते हैं जब दोनों एराइल है, और जब एक एराइल और एक एल्काइल है, one is the aryl halide, one is the alkyl halide, at that time it is Wood's Fittig. Wood's is for alkyl, Fittig for aryl. Okay, students? So, three equations we have done: Wood's reaction, Fittig reaction, and the Wood's Fittig reaction. Okay, students? Now, the next chemical property we are taking is reduction. As we did in alkyl halides also, alkyl halides on reduction gives alkane. So here also this aryl halide or the haloarene on reduction in presence of some reducing agents, students, it also gives what? Benzene. Here the reducing agent can be any, students. Nickel, aluminium or its couple can be taken as reducing agents. So on reduction of alkyl halides also we are getting benzene. Okay. Now after nucleophilic substitution we are taking ring substitution. In the ring substitution reaction is taking place, and that is electrophilic substitution. Why electrophilic substitution? What are electrophiles? Electron deficient species, positively charged species. So as you know, students, that in case of aryl halides like chlorobenzene, resonance is taking place, and due to resonance what is happening? This negative charge develops either on ortho or on para position. You are observing this due to this circulation of this bond. Lone pair of electron is circulating within the benzene ring, developing negative charge densities over ortho or para position. That you are knowing, student, how to resonate this bond in the benzene ring. So due to the development of this negative charge on ortho or para position, electrophile easily attack over these positions. Okay, students? So here firstly I am taking halogenation. All the mechanisms also we have done in 11th, students. So during halogenation, halogen is reacting with chlorobenzene or any haloarene. So here I have taken like Cl2, X2 we can take. In presence of anhydrous FeCl3, anhydrous AlCl3, Lewis acid which acts like carrier, students. So what we are getting? This chlorine is moving towards either ortho position or towards para position. Here Cl, heterolytic cleavage, creates electrophile and that moves either towards ortho or towards para, because negative charge is coming over these positions only during resonance. Okay, but in these two, ortho and para position, major product is para isomer. Why is it so, students? Because of more stability. That also we have done. Because of more stability, this para product, para isomer is more, or the major product, 80%, 20%. Okay, students. Then next is nitration. Nitration take place in presence of concentrated HNO3 and concentrated H2SO4. So concentrated HNO3 in presence of concentrated H2SO4, this mixture is called nitrating mixture. So in presence of nitrating mixture, this nitration is taking place. Here nitric acid I have written like this, OH and NO2. It is HNO3 only. I have written in this way so that you can be sure that what is electrophile and what is nucleophile here. So this NO2 1 positive is acting like electrophile. It is approaching towards ortho or para position and extracting out H plus from that to form H2O. So here what we are getting, nitro group is getting attached either over ortho position or towards para position. Is it okay, students? Here also we will say that this para isomer will be major product 80% and 20% because of more symmetry. Okay, more stability. Here next is sulfonation, students, which take place in presence of, or the reaction take place with concentrated H2SO4. H2SO4 also I have written OH negative and HSO3 1 positive. So electrophile is HSO3 1 positive. During the reaction, this HSO3 moves to ortho or para position, extract out one H positive from there to form OH negative and H positive to form water. Major product is this. Sulfonic acid group is adding either on ortho or on para position. So these were the electrophilic substitution reactions, friends. One, I am giving you homework, Friedel-Crafts alkylation and Friedel-Crafts acylation. Do these reactions by your own, friends. If you can't, if you are not able to do that reactions, ask me. I will tell you in my next video. And in my next video, I will complete this chapter, students, and then I will give you assignment questions as holiday homework from these two chapters, surface chemistry and this haloalkanes and haloarenes. Do that questions or holiday homework in a separate copy, assignment copy, students. In future also we will use that copy for doing different assignment questions after the completion of each chapter. So be sincere, students, be regular. You will be getting holidays from the school, but your coachings will be going on, I know. So keep on studies, give proper emphasis on studies, students. I will be uploading next video by tomorrow or day after tomorrow. So for today, this much is there. Thank you, students.